Okay, so in example 4, we're going to analyze a little more detailed problem using the Cauchy integral formulas. So we have this function z cubed plus, z cubed plus 3 over z times z minus I squared, and we want c, the contour that we're integrating over, is not a simple closed contour anymore. It's the figure 8. So c is, this guy. All right, so in this in this figure 8, we can break it up into two pieces. We can have C1, which goes the correct way, counterclockwise, and then C2 is the incorrect. Well, it's the opposite way, so it's clockwise. So I have a mistake here. So I want to integrate over C1, but then the integral over C2 is going to give us this guy would, if we didn't put a negative sign there, would give us the value this way. It would give us the value the opposite way. We don't want that value. We want the value going the clockwise direction. And so we subtract off the contour, the integral over C2. So let's do each one of these separately. All right. Now, C1 has the singularity I, so what we want to do is we want to rewrite this as z squared over 3 over z minus I squared. And, sorry, z squared plus 3 over z, my bad. So there's some really loud thunder that just happened. Okay, so we do this because z squared plus 3 over z doesn't have a singularity inside of C1. So it's analytic in a neighborhood of C, C1, and interior to it. So what we want here is we want this guy to be f1 of z. And since this is a 2 here, the Cauchy integral formula for derivatives is going to say this is going to be 2 pi I f1 prime, the first derivative, it's always one less, at I. So the singular point here. So we just need to compute f1 prime. Let's compute that real quick, maybe over to the side here. That's d dz of, let's see, z squared plus 3 over z is the same, z cubed over plus 3. Z cubed over z is z squared, and 3 over z is 3z to the negative 1. So the derivative is going to be 2z minus 3 over z squared. All right, so we'll go ahead and plug I into that. So that's 2I minus 3 over I squared. So that's 2 pi I times 2I, that's negative 4 pi. And then, let's see, I squared is negative 1, so that's going to be a plus 3. So we're going to get a plus 6 pi I. So that's the value for our first contour integral that makes up our computation. And that's the correct way, so we don't want to change any signs or anything like that. Now for the integral over C2 of z cubed plus 3 over z, over z times z minus I squared dz. C2 has the singular point 0, so we want to go ahead and appropriately isolate that. So we have z cubed plus 3 over z minus I squared over z dz. And the power that of the polynomial that contributes to the singularity is 1. So this is just the regular value of the function using Cauchy's integral formula. We don't have to take any derivatives. So if we call this the function f2, then this is going to be 2 pi I times f2 at the singular point, and the singular point here is 0. So we're going to get 2 pi I times, let's see, 0 cubed plus 3 over 0 minus I squared. So that's 2 pi I 3 over I squared, that's negative 3. So we get negative 6 pi I. Great. Now the value of the integral that we wanted, just regular c, not any c anythings, is going to be the difference of these two, where we subtract off the one we just did. So the previous value we got was negative 4 pi plus 6 pi I. And we're going to go ahead and subtract off negative 6 pi I. So it'll be negative 4 pi plus 12 pi I. And that's going to be the value of this contour integral.